Good afternoon and welcome to lecture 17 of ECL 706. In this class, we are going to cover some issues pertaining to slab and beam formwork. As what we will do is, we will try to cover some of the features of conventional slab and beam formwork, and then we will see some of the proprietary formwork such as the DOCA formwork, the Perry formwork, the LNT formwork and My1 formwork. So, this is how we are going to proceed. I have just made a tentative outline of presentation. So, first we will cover the various issues involved in conventional system of slab formwork. Then we move on to proprietary slab formwork. There we cover this LNT formwork, DOCA formwork, Perry formwork and then My1 formwork. These are some of the widely used formwork systems. Then in one of the lectures I will cover some design aspects for slab and beam formwork, both for conventional and proprietary, and in this lecture itself I will cover some practical examples from the field. So, this is how we are going to proceed for slab and beam formwork. Going to this conventional slab and beam formwork, I have given you some views through which you can just try to understand how things are done in conventional slab and beam formwork. This you can notice, this is for beam, and this sketch shows both for slab and beam. You can see some of the components are common here as well, what we have seen in case of wall, column and foundation formwork. So, the member which is in immediate contact with concrete, you can see these are sheathing member. This is what has been written here, these are sheathing members. In conventional slab and beam formwork, they are made out of either plywood or you can use even timber planks. Then the member supporting these sheathing is known as joist. In previous cases we have been referring to this as studs. Now, in case of slab and beam formwork, they are referred to as joist. Members supporting these joists are referred to as stringer. So, you can see this is stringer, this is what stringer is. Basically, they are supporting your joists. In addition to this, you have these props. You can say this as props or shores. They are also referred to as shores or prop. Okay. So, components are clear to you? Technology class? Okay, so you have sheathing, you have a joist, you have a stringer, you have a props. These are the basic elements of any slab and beam formwork. Besides this, there are certain other components also. For example, if you see in this particular slide, you can note this component which is just this triangular component, something like this. These are placed, these are known as T head, and these members are kept at the bottom of beam. So, if this is your beam, so for small width of beam, I will show you some, I will try to draw some sketches and then it will be clear. If your width of the beam is small, suppose of the order of 250 to 300 millimeter, then you can use these components. Something like this. So, these are known as T heads. T heads. So, even a single prop with a T head, and this is your prop. So, T head on top of prop is sufficient to take care of this much width of the beam. Now, when the width of the beam is more, what we do is, suppose you have a beam which is of let us say this much width, maybe this width could be of the order of 600 to maybe 800 or maybe even 1000 millimeter. In such cases, you will find that the T heads are not appropriate, they will not be able to take all your loads. So, in such cases you will find that the props are arranged in 2 rows. So, this is your supporting member, one row of prop would be somewhere here, another row of prop would be somewhere here. Is this clear to you, technology class? This is your beam. Do you understand this, technology class? So, this T head is for small width of beam, this 2 row arrangement of props is for large width. Okay. Now, we go back to what we were discussing here. This is the arrangement for beam. You can see on sides you have this plywood, on sides you have this plywood here, these are plywood, at the bottom also you have plywood, and then you have these supporting members, you call them as joist, and then you have these members, stringers. So, this is how your components are arranged. Some more picture, you can see some more figures of conventional beam formwork. It is possible to use this chamfer strip here as well. So, suppose if your beam is of this shape, that means edges are not sharp, you can put this chamfer strip here. So, this is in contrast to an arrangement like this. So, in this case the edge is sharp, here the edge is something like this. So, you can add one more member called chamfer strip, right. Rest of the things are same. Sometimes you connect these two sides of the beams with wire tie. So, these are your wire tie. Okay. So, this component could again be separate. This is one simplified version here, where you can clearly see some of the members. For example, this is your sheathing. Underneath this you can find this is your the red one is your joist, and I will use different color here. These are your these are, I am using the same color, these are your stringers, and finally I will show you the props or shores. So these are your shores. Is this clear to you, technology class? Okay. Same thing for beam. Here you can see this is your T head, this is your T head, and this has been used for beam. So I will just note it down once again, some of the components. So the yellow one is sheathing material, in this case it is plywood. Here is your joist. In conventional they are made of timber sections. Then this is your stringers, and finally these are your shores or props. Shores sometimes referred to as props. Okay. Now sometimes when the height of floor is more, suppose right now the height is this one, floor to floor height. Suppose in case this height is more, suppose the height is something like this. Okay. In such cases you may have to join two shores, something like this. So one shore is here, another shore is here, they are clamped. I will show you some other sketch through which it will be clear. For example, you can notice these two shores, they are connected with each other. Can you see this, technology class? So this is your plywood board sheathing. These are your joists, and perpendicular member here is stringer. Then these are your shores, and the shores are attached with one another in this manner. So you have this top post, top shore or prop, whatever you call them, they are all same. This is your bottom post. Okay. Then you have this clamp. So you have these clamps which are tied with nails. So there is an arrangement through which you can combine two posts one upon another. Is that clear to your technology class? So now you understand what are the components and their functions in case of conventional slab and beam formwork. Is that clear to you? Okay. Now we move on to see some proprietary formwork for slab and beam. Now this arrangement, what you see here, is provided by LNT formwork. You are already familiar with some of its component. What they do is they use this plywood. So here you have this plywood both for slab as well as for beams. The usual thickness of plywood is 12 mm or 19 millimeter depending on your design. Then underneath this plywood they use this H16 beam, which is having a cross section like this. As I told you, these beams are made up of timber and plywood. So the yellow one, what you see here, you can refer to them as joists. So joist here is made up of H16 beams. Now stringers also, you can notice this beam here. You can notice this beam in perpendicular direction. So this is your stringer and they are also made out of H16. and then this stringer is resting on a component called four-way head. And then this is your prop or shore. These are made up of tubular steel pipes and they are very strong. So, do you understand these components, technology class? I will try to show you. Yes. I will tell you. I will tell you. I will tell you. Don't worry. I will just clarify it. First, I will show you how the four-way head would look like. See, this is a plate, steel plate. Now, this plate has 4 cleats, something like this, and here you have one member. I will tell you in section how it looks like. So, this is your sheet, thickness of sheet, this sheet, and then you have this member here. Something like this. Now, this particular thing goes inside the prop. This particular thing goes inside the prop. So, this is your prop. Is this clear? Why we provide this is like this. You have one H16 beam here, something like this. So, the width of this width can accommodate 2 H16 beams. This spacing can accommodate 2 H16 beams. So, the advantage is that in case you find that the length of H16 beam is not adequate, you can lap them. So, one H16 here, another H16 here, they are simply touching to each other, that is it, and they are on the four-way head. Is it clear to you? So, another H16 beam may come here and rest something like this. It is not to scale, but just for your guidance. So, do you understand the purpose of H16 beam? If I have to make a section, it would be something like this. One H16 here, another H16, is this clear, technology class? Clear or no? Okay, fine. These angle members are very small, just a piece, something like this. It is welded here, these are welded here, so that it gives you a groove in which you simply keep the H16 beam, that is it. Hope it is clear. Okay, fine. Okay. Now in this slide you can notice one more component, which is this one. Just a minute. You can notice this blue component here, both faces. Now these triangular components are known as beam forming support. These are known as beam forming support. With this component you can do small widths of beam, small width and small depth of beam. So especially for a housing project, suppose you are building, suppose you are constructing small buildings, so the beam sizes are not great. Okay, so for such applications you can use this beam forming support. The advantage is you can see there is no use of timber. Timber is not required at all. So how it has been done is like this. You have H16 beam, you have, rather this is H20 beam for forming the sides. So here you have plywood, you can notice this is the plywood and there is one H20 beam here, right, both sides, and then this is a steel component. The blue one is the steel component, right. So with this you can manage maybe up to 600 to 700 millimeter depth of beam without using any timber. Now I will show you if the beam width is, beam thickness and width is more, how the arrangement looks like. I will just try to make one small sketch. Right now what you saw here was, you have this, suppose this is the beam that you want to do. Okay, so I am using this as a plywood, sheathing as the plywood. So this is sheathing, for bottom also you have used plywood, fine. Now what we are doing is we are making use of H20 beam to support the plywood. Okay, both sides similar arrangement, and then I have another component here, something like this. Something like this. So can you visualize how the pressure is taken care of? So for this height, concrete pressure is exerted on this, and this gets balanced by this clamping arrangement. So you have this nut through which you can tighten it, and this member is having a clamping arrangement here. So this H beam and this, they are connected together with the help of a clamp. So it is something holding the flange of H20 beams, which is this one, and then you tighten the screw so that the lateral pressure is taken care of. Can you understand this? Can you understand this? Now if I show you this figure again, so there is a clamp, you can notice here, which is holding the flange of this beam, flange of this beam. So it is clamping. Can you focus on me? There is a clamp which holds the H16 beam, something like this. Say for example, this is your flange, so it will just go and hold it tight, okay, and then there is a nut through which you tighten it so that it is able to resist the pressure. Do you understand this? Okay, so this is how the arrangement works out, but as I told you, this arrangement is suitable only for smaller beams. More than this, the press, if you have higher depth, the pressure would be too much and this clamp and friction arrangement will not work, right? So for larger depth of beams, you again go it with timber. I will show you how. This was for smaller beam. Now I will show you for larger beams. Suppose this is your beam. So you have this as plywood. Again this is your plywood. Depth here is very large. So you put some timber here. Then you have another layer of timber here, right, and this is the beam sides made of timber, right, and then you can support it here, something like this, with the timber itself, something like this, and then you have two layers of maybe props. So do you understand this? In conventional manner, we do this large depth of beam. So you have this ply and timber. Now compare this with this. Here we are not using any timber, no timber. Here all timber only. So is the difference clear? So naturally you will find that this arrangement is economical. Clear? Can you see me, technology class? Power failure?